So this is number 53. Specific heat capacity of octane is how many joules are needed to raise the temperature of 80 grams from 10 to 25. So it's asking for the Q, or the delta H if it's heat at constant pressure, is equal to M times C times delta T. And we're told that we have 80 grams, so 80 grams goes in for the M. Our specific heat capacity is 2.22 joules per gram Kelvin. And then our temperature goes from 10 to 25. So 25 minus 10, final minus initial, gives us 15. And that space in between is the same for Celsius and Kelvin. So it's 15 Kelvin. Now we multiply those three guys together. This is number 53. And the answer is 2.66 times 10 to the third joules. Or if you want it in kilojoules, it doesn't ask for kilojoules, it just asks for joules. So that's letter A. Letter B, it says, which will require more heat? Increasing the temperature of 1 mole of this C8H18 by a certain amount, or increasing the temperature of 1 mole of H2O by the same amount. So if we calculate the molar heat capacity of octane and compare it with the molar heat capacity of water, then you can know which one would take more energy. So in the previous problem, we calculated the molar heat capacity of water. That was right here, 51, letter B. And so for H2O, the molar heat capacity was 75.4 joules per 1 mole per degree Celsius. Now for C8H18, we're told that the specific heat capacity is 2.22 joules per gram degrees Celsius or Kelvin, and we have to change this from grams to moles so then we can fairly compare how much energy it would take to raise 1 mole of water or 1 mole of this octane. So put grams of octane, C8H18, in a position where it's going to cancel, and put moles of octane as our new set of units. And when we add up C8H18 on the periodic table, it's 114.2 grams. And so my molar heat capacity ends up being 254 joules per mole, 1 mole, you can put there if you want, degrees Celsius or Kelvin, because the space in between is the same. So now compare these two, and it looks like it takes 250 joules for 1 mole. Here it takes 75 joules for 1 mole. And so the molar heat capacity of the octane is greater than that of the water. So it will require more heat to increase the temperature of octane than to increase the temperature of water.